In this tutorial, we will be discussing the second review, the Part 2 review for Exam 2. This particular review is going to be focusing more on the math. So we're going to start with Avogadro's number. 6.022 times 10 to the 23rd particles per mole. When we say particles, we're referring to atoms, ions, molecules, and formula units. The term particle is a very generic term, and it can mean any one of those four things. So when you figure out, when you're trying to look at your problem, make sure you look at what they're talking about. For instance, Na3N, sodium nitride, is considered a formula unit because it has a metal and a nonmetal. It's a cation and an anion. And it can be broken down into ions. So it starts as formula units and breaks down into ions. CO2, that's nonmetal, so that's a molecule. And molecules can be broken down into atoms. Copper 2 sulfide is CuS. Once again, that's an ionic compound, so therefore it's a formula unit that can then be broken down into ions if the question refers to that. The representative particle for aluminum is an atom. For Na plus would be ion because of that charge. And then sodium chloride would be formula unit. So, 0.200 moles of H2O contains how many molecules? Notice H2O is a molecule because it's the two nonmetals bonded together. So that's why we're able to use that number. So 0.200 moles of H2O over 1. Whatever's on top goes on bottom of the next one. Because we're looking at molecules, we're going to use Avogadro's number. I'm going to try to keep reinforcing the idea of what number to use when. Alright, so 6.022 times 10 to the 23rd molecules is equal to 1 mole. So we have moles on the bottom. 1 goes with moles. And then 6.022 times 10 to the 23rd molecules goes on top. So it'd be 0.2 times 6.022 times 10 to the 23rd. That comes out to be 1.20 times 10 to the 23rd molecules. Now, if you get something like 1.20 times 10 to the 22nd or 24th, you want to make sure that you are actually putting this into the calculator correctly. Make sure you do EE or EXP when you're putting that into the calculator. A lot of the times is going to be a second function. So second function EE23. If you do not know how to do that properly, make sure you see your teacher ASAP, because that is crucial. You will get the problems wrong. Alright, so let's try another one. 0.450 moles of Fe contain how many atoms? Fe is an atom, so I don't have to convert it down any further. 0.450 moles over 1. I see the word atoms, so I know I need to use 6.022 times 10 to the 23rd, because that's the key term. Atom is one of the 4 key terms for Avogadro's number. I have moles on top, which means I want to put moles on the bottom of the next one. 1 goes with moles. 6.022 times 10 to the 23rd. Atoms goes on top. So it'd be 0.45 times 6.022 times 10 to the 23rd, which comes out to be 2.71 times 10 to the 23rd atoms. Alright, so let's move on to molar masses. Now, molar mass can have several different names. It could have atomic mass, molecular mass, or formula mass. Don't get confused. The process is always the same. It just all depends on what representative particle it is. So, for instance, Na3PO4 is an ionic compound because we have a cation and an anion. So you just figure out what each of the components are worth. So sodium, we have 3 sodiums, we have 1 phosphorus, and we have 4 oxygens. Then you look on the periodic table and you look for sodium. That is 23.0. So 3 times 23.0 is then equal to 69.0. Phosphorus is here, and its mass is 32.1. So 1 times 32.1 is 32.1. And then oxygen is here, and it's 16.0. So 4 times 16.0 is 64.0. Add those all up, and it comes out to be 165.1 grams per mole. You might also see AMU. Don't be confused by that. AMU is the actual correct one, but a lot of people just go ahead and put in grams per mole, so that way we can convert it when we do the calculations. Let's try another one. Calcium hydroxide. We have calcium, oxygen, and hydrogen. We have 1 calcium. Now this 2 on the outside gets dispersed, so that means we have 2 oxygens and 2 hydrogens here. Calcium is here, and it is 40.1. So 1 times 40.1 is equal to 40.1. Oxygen is here, 16.0. So 2 times 16.0 is 32.0. And hydrogen is here, 1.0. 2 times 1.0 is 2.0. Add those all up, and it comes out to be 74.1 AMUs, or grams per mole, depending on what your choices are. Alright, so let's try to start taking these and using them in the calculations. So we have grams. Grams are one of the key terms for molar mass. So before I go on, I need to figure out the molar mass of KMnO4. So we have 1 K, 1 manganese, and we have 4 oxygens. So K is here, and it comes out to be 39.1. So 1 times 39.1 is 39.1. Mn is right here, and its mass is 55.0, which comes out to be 55.0. And then oxygen is here, and it's 16.0, which 4 times 16 comes out to be 64.0. Add those up, and we have 158.1 grams per mole. Now, just like miles per hour, that's how many miles you drive in 1 hour. This is how many grams are in 1 mole. So that means this number that we calculate will go with grams, and 1 will go with moles. Notice so far everything with moles is always 1. The number actually goes with the other unit. So 25.0 grams over 1. We have grams on top. That means we want to put grams on the bottom of the next one. That's 158.1. And that is equal to 1 mole. So 25 divided by 158.1 comes out to be 0.158 moles. Calculate the number, how many moles are in 17.0 grams of H2O2. Once again, the term grams means that I need the molar mass. So HO, we have 2 hydrogens and 2 oxygens. Hydrogen is 1.0, which comes out to be 2.0. Oxygen is here, 16.0. That comes out to be 32.0. Add those up and we get 34.0 grams per mole. Put the number we're trying to convert over 1, so 17.0 grams over 1. Grams are on top, so I want to put grams on the bottom of the next one. That's 34.0 is in 1 mole. So 17 divided by 34, and that comes out to be 0.412 moles of H2O2. So when exactly do we know what to use what? We're going to use Avogadro's number when you see one of these 4 key terms: molecules, atoms, ions, and formula units. When you come to molar mass, you're going to either see the word mass or grams. That's how you know when to use that. If you have a funny feeling you're going to forget that, write it down. Memorize it. That's super important. Moles will always be used in both conversions, so don't go to that one as a telltale sign. In fact, a lot of times we need to convert to moles and then go to the other one. It's the one thing that relates both of them. So let's do an example of that. Calculate the number of atoms. I see the word atom, so I think 6.022 times 10 to the 23rd. And 7.50 grams of iron. Grams tells me that I need to figure out the molar mass, so I need to look at the periodic table. And I find out that iron is here, and it is 55.8 grams per mole. I only have one of them, so I don't have to multiply it out or anything. Now that I have all my key numbers and key terms, I can go ahead and solve for it. So 0.750 grams of iron over 1. I have grams on the bottom, so I want to put grams top, so I put grams on the bottom of the next one. 55.8 goes with grams, and that's 1 mole. I have moles on the top. A lot of times I'll cross out what I've already used so I don't use it twice. Moles on the top, so I put moles on the bottom. Now I'm going to use Avogadro's number for atoms per mole. 1 goes with mole. That is equal to 6.022 times 10 to the 23rd atoms. So 0.75 divided by 55.8 times 6.022 times 10 to the 23rd. That comes out to be 8.09 times 10 to the 21 atoms. Now keep in mind, if you have something different up here, chances are you're probably putting the times 10 in wrong. Make sure you do that properly with the EE button. Let's try another one. What is the mass? So I see the word mass, which means I need the molar mass of CH4. So before I go on, let's do CH4. So we have C and H. We have 1 carbon and 4 hydrogens. Carbon is here at 12.0. So 1 times 12.0 is 12.0. Hydrogen is here at 1.0. So that is equal to 4.0. So combine that, and it's 16.0 grams per mole. Alright. What is the mass of CH4 molecules if they are made of 1.50 to 10 to the 23rd molecules? Molecules is one of the 4 key terms for 6.02 times 10 to the 23rd molecules per mole. Alright, so now we have all our numbers that we need. So 1.50 times 10 to the 23rd will be our starting number. Alright, so we have molecules on the top, which means I want to put molecules on the bottom of the next one. That's 6.022 times 10 to the 23rd. That is equal to 1 mole. Now we have moles on the top, which means we want to put moles on the bottom. We've used this number, now we're trying to get to mass, so we're trying to get to grams. So 1 mole is 16.0 grams. The moles cancel. The molecules cancel. So it's 1.50 times 10 to the 23rd divided by 6.022 times 10 to the 23rd times 16. That comes out to be 3.98 grams of CH4. Alright, we're going to try one last one for this video. Calculate the number of molecules. I see molecules. So 6.022 times 10 to the 23rd per mole. In 1.058 grams. I see the word grams, so that means I need the molar mass. So I have HO. I have 2 hydrogens at 1.0, which comes out to be 2.0. And I have 1 oxygen at 16.0. So that comes out to be 16.0. I'm going to add those together, and that's going to come out to be 18.0 grams per mole. This is our starting number, 1.058 grams over 1. Grams are on top, so I want to put grams on the bottom. 18.0 grams is equal to 1 mole. We have moles on the top, that means I want to put moles on the bottom. We're trying to get to molecules, so we're going to use this number. We have 1 mole, 6.022 times 10 to the 23rd molecules. So 1.058 divided by 18 times 6.022 times 10 to the 23rd. That, when you calculate it out, comes out to be 3.540 times 10 to the 22nd molecule. So hopefully this was actually fairly easy for you, because if it is, that means that you've really got it. If not, now you know what you need to review. And this is the end of the second part of the Exam 2 review.